Okay, on to the next problem. So we are working on a painting demo. Creates an array of 8 room objects. So we need a room class in order to create a room object. So let's add a new class called room. Let's mark that as public. We've got some fields, so let's make some instance fields. Length, width, and height. Private. Let's just go with whole numbers. Int width, length, height. So 3 instance fields. The constructor requires parameters for all 3. Public room. Man, sometimes my IntelliSense is right spot on. Okay, so we have a constructor here for all 3 inputs. The room class also contains a field for the wall area and the number of gallons needed to paint the room. Okay. If you multiply a bunch of ints, we're going to end up with a whole wall area and num gallons, private int num gallons to paint the room. So the wall area can be configured, and so can the num gallons based on some specifications here. And so you kind of read through how do you calculate. Basically, we have to calculate the wall area and the number of gallons. It does mention include read-only properties to get the room's value. So notice we're putting the data in here to... It's like the microphone is listening. Public int width, get return width. Length, return length. Height, return height. It's weird. You ever heard people, conspiracy theorists, say the computer's listening to me? It is. Yeah, TikTok is. You're right. You're right. And you agree to it when you click the button that says I accept. You're right. So it's really not conspiracy. It's social media. Okay. So these are, what are these? These are read-only properties. Read-only properties, meaning they only have a get block, they don't have a set block to get the instance fields. This is a constructor to set the instance fields. Now, here's a little bit of math to calculate the square footage of a room, as well as the number of gallons of paint that are needed. It does mention both of these values are computed by calling private methods. See this right here? So these fields are calculated by calling private methods. So these fields right here are calculated fields when you call private methods. So we need to maybe make a method. I'm going to make this a private method because that's what it says. It's going to be void. We're going to say calc wall area. Okay, now the wall area is this. You're going to have 4 walls. So it's going to be the length times the height for one wall. Length times height for that square footage of the wall. But presumably, if it's a square, you're going to have 2 of those walls of the same dimension. Length times height times 2 plus width times height times 2. So that's like the other 2 walls. Like the room's length times the height, that's that wall times 2 because you got 2 of them. The width is that wall times the height times 2. Now you got 4 walls, right? So this is interesting. We can directly access the width and the length and the height through these properties, right? So this could be calculated like this. We're going to set the underscore wall area equals the underscore length times the underscore height times 2 plus underscore width times underscore height times 2. So this private method calculates the wall area field, and we can call this method from our constructor. Once we set the width, the length, and the height, let's just go ahead and call calculate wall area right here to calculate, well, just like it says, calculate wall area. And number of gallons. How do you calculate number of gallons? 1 gallon of paint for every 350 square feet, plus an extra gallon for any square footage greater than 350. Okay, so there's basically, you could do like integer division, divide one int by another int to get a whole number of gallons by 350. So let's write another private method. Private void calc num gallons. And we're going to set the num gallons equal to, well, this math is like this. One int divided by another int is integer division. So I'll say int gallons equals wall area. Wall area is an int. So initially my gallons is wall area divided by 350. Right here, wall area divided by 350 is one int divided by another int. So we got int divided by int, the result is an int. Then I'll say if underscore wall area divided by 350 is not equal to 0, if there's any sort of remainder, when you divide by 350, if it's not an even divide, let's set gallons plus plus. Gallons goes up by 1. So this gets us an initial number of gallons. This says, hey, if there's any sort of leftover area, let's increase it by 1. And then we're going to set num gallons equal to gallons. That little variable that we made, this local int. Okay, so this calc num gallons can also be called from our constructor. Calc num gallons. So when you call this constructor, you're setting all 5 of these fields. It just so happens that these 2 fields are calculated, and we wrote that logic into methods and then called those methods. Okay, so now I think we have met all of the requirements. So they give an example of a 12 by 10 room with 9-foot ceilings, and it should be, 396 square feet with 2 gallons of paint. Okay, so I'm going to input that data and use that as my initial test. Any questions on this so far? So let's go put a button click in here. View room data. Button rooms. And let's put a label here. Properties called label result. And auto size, let's just get that nice big result label with no text. Now this says an array of 8 rooms. Okay, we can do that. Let's have a room array called my home rooms equals new room array. We're going to use this initializer like we learned about in the last problem, new room, and it takes a width, a length, and a height. Now this was 12 by 10 by 9. So this room, the width, the length, and the height, I believe 12, 10, 9. No semicolon. Okay, so right now our room array just has one room in it, but I just want to see. Now I've got the width, length, and height properties, but I don't have any way of getting the area and the number of gallons out. Like I put this data in, but I don't have any way of getting the data out. Let me see what it says. Constructor parameters. Okay, I'm just going to use a toString because toString is for the win. toString is one method that can kind of get a bunch of data. So I'm going to write one method to get all the data out, and then you really don't even need these properties. Public override toString. And we're going to print out all of this information. A room with a width and a length and a height has an area of this and will need this many gallons of paint. A room with a length of, no, here we'll say this by this. So we'll say a length by height room with height ceilings, a 12 by 10 room with 9, I guess you would,
width instead of height on one of those length by width with a room of height.
oh, thank you, length by width. At least one person's paying attention, I appreciate that. A length by width room with a height ceilings with 12, I would say foot ceilings. Has an area of underscore wall area and will need num gallons of paint. So this one toString can kind of get a bunch of data out for me, so that's nice and clean. And if I go back here to my room and I set my label result.text is my home room sub 0, that's the one room I have in there, toString. So I have an array of 1 rooms, put the data in, pull the data out. Now there's a whole lot going on behind the scenes here. I really like this problem because all you're inputting is dimensions, but what you're outputting is area and number of gallons of paint. Okay, I've had students go make software for the construction industry where they're doing this kind of, they're going to give you some basic inputs on some blueprints, and you need to calculate how much electric cable is needed, how much water piping is needed, how many lighting fixtures you need to order. Okay, so you take in a little bit of input, and the software calculates a whole lot of output based on that input. And so I think this is a small example of exactly that. And it's all being done in this constructor call. In this constructor call, you have the data going in, and it's calculating number of lighting fixtures, wall area, number of gallons, et cetera, et cetera. It's a good problem, yeah.
Will we be same example problem? It probably wouldn't be too dissimilar, but instead of getting like hard variables that we put in, we have to use user.
Yeah, I can do that real quick. I can do that. A 10 by 12 room with 9-foot ceilings has an area of 396 feet and will need 2 gallons of paint. So let me clean that output up. Need 2 gallons of paint. Has an area of this many square feet. A 10 by 12 room with 9-foot ceilings has an area of 396. That's what the problem says. And we'll need 2 gallons of paint, which is also correct. Okay, now let's get user input, right? So let's do a label for the width. Text box here, properties, text width. Ooh, let's not put that inside of my label. Okay, copy paste. One for the height. And one for the length, right? Width, length, height. Okay, so width, length, and height, and let's align their lefts so they're all lined up. And let's click on this button, and let's say int width equals text width dot text convert to int 32, int height, int length. You with me? So we get our 3 inputs from the user. Let's construct our second room object, new room, passing it width, length, and height. So we just use variables instead of static data.
That's what I was thinking. I just
Yeah,
didn't know.
yeah. It probably helps. I'm sure it helps everyone to see that, right? So the first room is statically configured. The second one is dynamically configured. So let's run this and say 100, 200 by 9. And it's only outputting my 1. And because I've hard coded that, let's do a for each. Here's a different syntax. For each room.
Room and room.
That's right. Let's call label result dot text is room to string plus equals, and let me just make sure that my to string has a line break on it. It does not. Okay, so now say 100, 200 by 9. 200 by 100 room with 9-foot ceilings has that square foot and will need 16 gallons of paint.
Oh.
Okay? I haven't double checked and triple checked my math, but as you might have guessed, I've solved this problem before because I can fly through it. So I'm pretty sure it's good. Then what? I mean, it says do this with 9 rooms. Well, three, 4, 5, 6, 7, 8, 9. You get some really small rooms. It's like jail cells. You're put in the box in jail, right? 5 by 5 by 5. The hole. You're in the hole. What is that movie?
There's one example of it in the movie Life.
Life. There's a lot of movies where you're in a jail cell with really small.
Mile, yeah.
The Green Mile.
Reaction movie, I think.
Yeah,
Shawshank. Yeah.
There's like so many, it doesn't narrow it down.
No, it doesn't. But we got a bunch of prison rooms here. And of course, I still need to input my data, otherwise it'll crash. But because all of these rooms are so small, they only need 1 gallon of paint. Because anything under 350, we'll do that. So now we've got 9 rooms.
If you really want to go above and beyond, you calculate how many